Four 2 cross 2 cross 2 centimeter cubes of ice are taken out from a refrigerator and they are put in a 200 ml of a drink at 10 degrees Celsius. Find the temperature of the drink when thermal equilibrium is attained. And in the second part, if the cubes does not melt completely, then we have to calculate the mass of the ice that actually melted. Okay, we do have data given. Fine. So first of all, we do have 4 cubes of ice. Okay, so volume of each cube is clearly 2 cross 2 cross 2 centimeter cube, that is 8 centimeter cube. Okay, so total mass of ice can be written as density into volume into 4, because there are 4 cubes. So I have density as 0.9 gram per centimeter cube into volume, that is 8 centimeter cube, into 4. So the total mass comes out to be 0.9 into 32, that is 28.8 grams. Now total mass of water is given to me as 200 ml into density of water. So I do have 200 into 1 gram per centimeter cube, that is equals to 200 grams. Alright, and the temperature of water is given to me as 10 degrees Celsius. So first of all, I'll show you that complete ice will not melt. How? Okay, the temperature of the ice is equals to 0 degree initially. Agree with that? Fine. So if let's say 28.8 grams of ice convert to water at 0 degree, so Q latent, that is the heat that will be liberated or the heat that will be required to convert 28.8 grams of ice into water, is equals to ml, that is 28.8 by 1000, that is mass in kg, and the latent heat of fusion, that is 3.4 into 10 to the power 5. Alright, that comes out to be 9792 joules. Alright, and let's say that the energy that will be required to convert 200 grams of water from 10 degree to 0 degree. So the Q that will be required to convert water at 10 degree to water at 0 degree, that will be equal to mc into delta T. So mass is 0.2 kg into 4200 into 10 minus 0. Alright, that comes out to be 8400 joules. Alright, now clearly that if complete ice melts down, then this much energy will be liberated, but only 8400 is required. So what happens is, complete ice will not melt, only that much ice will melt, which liberates 8400 joules of energy, so that final temperature will come down to 0 degree, because still some of the ice is remained in the mixture, so final temperature will be 0 degree as of now. Fine. So again, the mass, first of all, the temperature of the drink will be 0 degree, so the T final is 0 degree Celsius. Alright, now moving toward the second part, that is B. Now in which it is asked that the mass of the cube that actually melts. Okay, so clearly only 8400 joules of energy is required to bring the temperature of the water from 10 degree to 0 degree. So the mass of ice that will liberate 8400 joules of energy, that will actually melt. So this is M ice, is the ice that actually melts. So M ice will be equal to 8400 divided by 3.4 into 10 to the power 5 kgs that gives 0.0247 kg or 24.7 grams. That is my answer.